In this video, we're going to be looking at solving inequalities. Now, let's start out with something pretty simple to just review some basic ideas of solving inequalities. So we'll start out with a very simple inequality. 2x plus 1 is less than or equal to 7. So when you're solving an inequality, for the most part, solving inequalities is just like solving an equation, meaning with equals. In other words, there's really not a lot of difference between solving the problem on the left and solving the problem here. There is a couple exceptions, but I'll talk to that in just a second. So let's go ahead and talk about the one on the left, and we'll go ahead and work through this one. So 2x plus 1 is less than 7. If we understand that this basically works like solving an equation, then we know that our goal is to try to isolate the variable or to get the x by itself. And in this case, to do that, we would start with the plus 1 and we would do the opposite, so we would subtract 1 from both sides. Those would then cancel, leaving us with 2x on the left, less than 7 minus 1 is 6. And now we can focus on getting rid of the 2. And you always do the opposite operation. This is currently multiplication, so we will remove the 2 and get the x by itself by doing the opposite of multiplication, which is division. So if I divide 2 on both sides, 2's now cancel, leaving me with x is less than 3. Now, I did mention that there are a few things where inequalities operate differently than our equations. There's really only basically two scenarios. One is anytime that we multiply or divide by a negative number. As we're solving, when this happens, we must flip the inequality. And we'll look at that in just a moment with an example. But for right now, let's focus on the one we just did. Oh, messed that up there. Not inequalities, but inequality. Okay, so this is really the big piece we got to be careful of. All right, so let's come back to our solution that we just came up with. So we started out with this problem, 2x plus 1 less than 7. And if we interpret this problem, what we're trying to figure out is what are the x values that would make this left side less than 7 whenever you plug that in for x. Again, what are the x values that would make the left side less than 7? And our solution that we have come up with is x is less than 3. Now we just to kind of get an idea of what's going on here, and to test it out, we could figure out a number that is less than 3 and then plug it in and see that it is in fact true. So the easiest number less than 3 would be 0. If we put in 0 for x, then it would be 2 times 0 plus 1. Well, 2 times 0 is 0, 0 plus 1 is 1, and 1 is in fact less than 7. So you can see it does work. So this is one way of writing the solution. X is less than 3 for this problem. Another way of doing the solution, you probably remember from earlier grades, is actually graphing it like on a number line. So on a number line where this is 0 in the middle, if that's where we choose to put in the middle, we don't have to. We could have just as easily started with 10 in the middle. It doesn't matter. But since the number that we're focused on for our solution is pretty close to 0, I'm going to choose the center to be 0, which means that here is 1, 2, and 3. Now, our solution is x is less than 3. The way we would represent that on our number line is it would begin at 3, and I'm going to draw that with the open circle, and then it would be everything less than 3. So the purple that we have here would be my graphical solution. Now, the reason I did this open circle is because notice that we do not have the equal to here under this inequality. It's not less than or equal to 3, but it has to be all numbers that are less than 3. And since there's no equal to here, that means that 3 is not a part of this solution. It's everything under 3. So since 3 is not a part of the solution, I can't fill this in. So I leave it as an open circle indicating that 3 is not a part of the solution. Okay, so we have the algebraic version of the solution. We have the graphical version of the solution on the number line. And one last method that we can do to write this solution is using interval notation. Interval notation you probably have heard before, but it's just another way of representing a set of numbers. And in our case, interval notation, the way we would do that is, if you imagine this number line drawing that we just did, the shading that we did here, imagine this shading having a left and a right, a start and a stop. So on the left, if we think about it, my start, since this goes on forever and ever down this direction, then my leftmost part of this would be negative infinity. And my rightmost would be 3. Now, I know we're not using 3, but that's where things kind of stop with our illustration of our solution. So I have negative infinity and 3. Here's my left, here's my right, here's my start, here's my stop. So building on that idea, interval notation kind of focuses on that left and right idea, or the start and stop. So my interval notation will be from negative infinity to 3. And this means by this comma, it's kind of like an ordered pair with graphing, but it is not an ordered pair. Do not get that confused. But what this means is go from negative infinity to 3 as part of your solution. Now, we need a way to represent this open circle like we did here. And the way we're going to do that is we're going to put a parenthesis here. Anytime you have infinity on either side, that side will get a parenthesis also. And again, we'll talk about this a little bit more in a second. Now, let's just suppose, for example, that instead of x being x less than 3, let's suppose that my solution was x is less than or equal to 3. Now, if this had been the solution, then graphically, on the number line, again, same idea, 1, 2, 3. We would have began here at 3, or this is my rightmost point. And this time, since the equal to is there, I would have done a filled in circle. Not an open circle, but filled in. And now it would still be everything to the left. So I would have the algebraic solution. I would have the number line solution. And now if I chose to do interval notation for this would be, remember, my left and my right. So I'm still coming down to negative infinity, still going to 3. So it's looking really similar. Negative infinity to 3. Now remember, I just told you with interval notation, if you're ever dealing with infinity, it always has a parenthesis. This time though, since the 3 is closed and included, it will receive a bracket. The bracket indicates to us that it was included, it was closed. So that's how interval notation works. Now that was a really simple problem. So what we're going to do is we're going to flip over and get into problems that are a little bit more involved. Okay, so here we have what's known as a compound inequality. The reason it's called a compound inequality is because it basically has two different parts, two different pieces that are all part of the same problem. And to see this, you could view it where the right side, imagine that the right side was not there. So imagine just for a second, let's see if we can take this off. Imagine that this was not there, and you would only have the left part. So you can see that's kind of like one inequality. On the flip side, we could also imagine this problem without the left side. And then you could see that inequality. So you can see how it's like two different inequalities put together. So if we realize that, to solve this problem, we can use that idea to split this problem into two individual pieces. And this would be negative 3 less than 2x plus 5, and 2x plus 5 is less than or equal to 7. Now it is important that we put and here because both of these things are happening at the same time simultaneously around this 2x plus 5. From this perspective, because of this being an and problem of this nature, this is often referred to as a conjunction. Conjunction is kind of like putting things together, and you'll see how this ties in just a second when we get down to the solution. So being that I have two parts at this level, let's solve each part individually. Now I'm going to go through this kind of quickly. So we'll subtract 5 from both sides, and that will be negative 8 less than 2x. and then we will divide by 2, and that will give me -4 is less than x. Now usually most people with inequalities like to have the variable on the left. It's just a little bit more familiar to read, kind of reading left to right. So imagine taking this entire inequality up off the paper and then flipping it over. Well, if we did that, it would become x is greater than -4. Okay, so here's this side. Now if we do the same thing over here on the right side, solving, subtract 5 from both sides, and we would have 2x is less than or equal to 2. Then divide by 2 on both sides, and I would have x is less than or equal to 1. So at this point, I have my two pieces of this solution. X is greater than -4, and x is less than or equal to 1. So my solutions to this compound inequality, the x values that will produce this center component being between -3 and 7 are x values that are bigger than -4 and smaller or equal to 1. So here we have the algebraic solution. Now let's look at see what the graphical solution would be. Remember, that's our number line. So if I get my number line, and we're dealing with -4 and 1, so I'll still put 0 in the middle, it's okay. And we'll go, this is 1, we'll go -1, -2, -3, -4. And I'll finish this out just so we can see it. Okay, so let's do this side first. So I am going to graph this piece, x greater than -4. Now, just kind of like you have scratch paper with some math work, I'm kind of going to have a scratch area here. So I'm going to begin at -1, 2, 3, 4. It's going to be an open circle because the equal sign is not under there. And greater than -4 will be everything this way. Again, that's at -4. All right, and then we have, and let's switch over here for a second. X is less than or equal to 1. Here's 1. Less than or equal to, so this one will be filled in, and it will continue this way. Now remember, we're dealing with and here. And means that both of these sides must be true at the same time. That means we must satisfy both conditions. And the only parts of these two green and red lines that are both true at the same time would be everything in between here. Now, here I have both because that's a filled-in circle, so I will put a closed circle there. Here I do not have both. I have the red line, but I don't have the green. It's an open piece, so I have to put that as an open circle. So my solution would be this on the number line. Notice, remember, and is both combined together, and you can see that happening. Now, we have the algebra solution, we have the number line solution, and now let's do our interval version of this solution, interval notation. Remember, interval notation focuses on a left side and a right side. So my left side is -4, my right side is 1, parentheses or brackets on each. This one is open, so it will have a parenthesis. Over here, it's closed, so it will have a bracket. And that is a conjunction. All right, so next we're going to look at the other side, and this is going to be our last piece to wrap it up, was known as a disjunction. Okay, so in this problem, we have what's known as a disjunction because I have two inequalities that are combined with the word or. That's going to give us our clue that it's going to be a disjunction. Now, for the sake of time, I'm going to go ahead and solve these out individually. Go ahead and have that done for us so we don't drag this out, and then we'll look at the solution. Okay, so there's a lot going on here, but I do want to bring your attention to a couple pieces really quickly. So the top part of this you can see where we get our solutions. And you will see that that is the solutions that we have here in algebraic form. Now, on the number line, this is where I did my graphical version. The red pieces are the individual pieces like the work area. Now with or, you do not have to have both of them at the same time. As long as you have either of them, it's okay. So that's why with this one, they just basically kind of transferred down to the final answer, which I have here in purple. Then when that happens, I now have my interval notation. Notice interval notation has a piece for each one And then to show that they're a part of the same piece, I definitely do need to put this union here to wrap them all up.